Alright, and welcome back to the second video for this chapter. We're now going to be talking a little bit about the somatosensory cortex in more detail. If you don't remember the homunculus and the somatosensory cortex, I highly recommend going back and watching the last few minutes of the previous video, because it's going to unlock everything that we're going to be talking about in this video. Alright, so let's first start talking about body image. Body image, very controversial, is a huge kind of area of research. It creates huge problems in our society. For example, eating disorders are a problem with body image. Eating disorders can cost people their lives. And so this is really important stuff. We know a little bit about it. There's still a lot that we don't know. One of the things that we have found, though, is that when you look at how the brain kind of represents the body versus how the body is actually shaped, we see they are different. So, for example, the average true body is kind of like this, where you have a little bit of a short torso, a little bit longer legs, and that the shoulders are usually a little bit more broad than the waist. But the kind of perception of the body as represented in the brain is different than that. It doesn't actually normally just by normal. No, I'm not talking about eating disorders here, but for most people, that body image is distorted in the brain, so that we perceive ourselves as taking up more space than we actually do. And so you can kind of see here that the average body image has broader shoulders, a longer trunk, shorter legs. For some reason, the arms are almost exactly the same, but you can kind of see the difference, that people feel like their bodies kind of take up more space than they actually do. And so for people that have eating disorders, what's proposed and what's hypothesized is that one of the reasons why that happens is because the brain kind of further distorts this body image so that you feel like you are taking up even more space than you normally do. And that's on top of the normal kind of societal pressures and behavioral routines and cognitive distortions that might otherwise occur with things like anorexia nervosa and things like that. If you're interested in that, there are certain capstone classes you can actually take in our department. For example, I think Dr. Bob Hayes offers a class on eating disorders every couple of years. So that's just a little bit of a taste of that area of research. Now for something a little bit more lighthearted. This is something that unfortunately, because you're online, you're not able to experience. And so this is like a really cool thing that I like to do in the classroom called the rubber hand illusion. And the rubber hand illusion is this really neat illusory effect where people feel like they are being touched when in fact they are not being touched. And it's wild. So check out this video whenever you get a chance, and you can see a guy doing this on normal everyday citizens, and it doesn't look like it works, but I guarantee you that it works. And if you can buy like a fake hand, a rubber hand on Amazon for like $13 or something like that, and you can play this at home. You can try it at home. I guarantee that it works. And if you do try to go through this and you want to try to demonstrate it on your friends and you're not getting it to work, let me know and I can walk you through the process. But basically, so I'm going to go ahead and assume that you've watched this video now, because I'm going to explain a little bit about what's going on. So what's going on in this video, basically you have a real hand and you have a rubber hand. They're right next to one another, but they're divided so that the participant can only see the fake hand. But importantly, it needs to look at least somewhat like a hand. While that's going on, the researcher is going to be stroking both hands, the fake and the real hand, in the same place at the same time. And so usually you'll have a feather or you'll have a paintbrush or something like that. And so you're going to slowly, kind of stroke both hands at once. And so the participant, they're sitting there, they're having their actual hand stroked, but they're not able to see their actual hand. They're only able to see the rubber hand. What happens is that over a short amount of time, the brain is going to start assuming that sensation, that feeling of being stroked like that, is coming from the fake hand. And so it kind of projects that perception as that part of that stimulus, that fake hand, is part of my body. And so there's lots of really cool research here. You'll see that there's lots of like kind of neurological evidence of this going on, where whenever people kind of see the hand being stroked and they falsely attribute it to themselves, that the part of the brain that perceives, touch lights up. And so this is a cool example of vision and touch working with one another. Part of why this works is through Bayesian perception. And we've talked a little bit about Bayesian perception just a little bit throughout the semester. And the idea is that it's very unlikely that you're seeing something that looks just like your hand that's being stroked at the same time in the same place as your actual hand. And so what happens is that we start to assume, well, what's the most likely outcome? Well, it must be that we are feeling that sensation from this source over here, which is not actually our real hand. So check that video out. It's pretty cool. That's going to lead us into what's called phantom limb. And some of you have probably heard of phantom limb syndrome before. It is kind of an interesting, fascinating example of psychology. I like to show it in my intro class when we talk about the brain. But basically, what phantom limb is whenever you lose part of your body. And so, for example, let's say that you're a combat veteran and you lose your hand or your arm from the elbow down. Very traumatizing, right? But what happens is that in the weeks and months after this happens, people will start reporting that they feel their hand actually there. That's why it's called the phantom limb. It's like a ghost. It's like it feels like it's there, but it's not actually there. And so this has been a very well-known phenomenon for centuries, right? Like people have complained and noted and detailed this kind of illusion for all of human history. And it wasn't really until recently that we discovered exactly why this happens. What happens is that, think about the body image, right? We talked about the body image at the very beginning of this video, that the layout of our body is represented on our brain. Now, if that body image is disrupted, so for example, we lose part of that body, our brain is still there, right? Our brain still has that kind of representation of our body. And so it creates this kind of conflict that basically there is part of our brain that is still responsible for perceiving that missing limb, but there's no actual limb there to provide its sensation. So what happens is essentially that we start feeling sensations there because that part of our brain is still active, it's still alive, it's still tissue, and so it will stay active, right? Because just because part of your brain is not being used doesn't mean that it just turns off forever, right? It's still going to kind of be active, and when that happens, we perceive that as it being touched. So that's part of the story. The other part of the story gets a little bit wilder, because what happens is that people like this, that have phantom limb, whenever they receive touches in unrelated parts of their body, will report that people are touching their phantom limbs. So a very common example here is if somebody were to lose their arm from their elbow down, if they close their eyes and somebody touches kind of their brow, their eyebrow, and their forehead, they will actually attribute that to them touching their missing limb, which is really scary, right? But the reason why that happens has to do with what we talked about at the end of the last video, the sensory homunculus. So if you look at kind of how our body is laid out, you can kind of see here this particular dude who lost his part of his arm. So he has all this missing part right here, but if someone were to close their eye and touch part of their face, why does it register as their arm? Why are they perceiving it as their arm? Well, if you look at kind of where the face is processed in the brain, the hand is very, very close to it, right? And so what happens is that as this area that's responsible for this missing hand, as it is not really being used anymore, neighboring areas will start covering it. They'll start taking over that part of the brain because it's not being used so much. And as we talked about, throughout the semester, the areas of our brain that we use most frequently seem to grow in strength in terms of the connections that they make. And sometimes they can kind of grow outward. They can cover more area for processing. And so that's exactly what we see here. So if somebody were to lose their hand, that part of the brain is still there, and eventually things like the elbow will start creeping in and taking over some of this real estate, and parts of the face will start growing and taking over this part of the real estate as well. So that is phantom limb. And what I just described to you about how different parts of the brain will start kind of growing in their function, or what kind of things that they process, that's what's called neuroplasticity. And you've probably heard about this in other classes as well. But basically, neuroplasticity is the idea that different parts of the brain will change depending on their use. And we talked about this, now that I think about it, we even talked about this when we were talking about greebles, if you remember that way back when we were talking about chapter 4 with object recognition, that the part of the brain that's responsible for perceiving faces can change, right? It can change depending on what we've learned. So here's a very typical experiment with neuroplasticity and how it works. So in this particular case, this fascinating experiment, these researchers had these participants come in and they blindfolded them. So they blindfolded them for 5 days. For 5 days, they were unable to take off their blindfolds. So they lived without sight for 5 days. And what they did is they came in each day for an MRI scan. And so what these researchers were interested in was the sensitivity of the right index finger of their hand. And so they came in and they would, have braille pads so that they could kind of feel these tiny little bumps on the tip of their right index finger. And so the first day, while these people were blindfolded, only areas in the somatosensory cortex were activated. So in other words, only the area that is responsible for touching the fingertip was active in the brain when that was happening. But by the 5th day, what happened is the area of the somatosensory cortex responsible for the right index finger decreased a little bit, and areas in the visual cortex increased. Wow, what the hell does that mean? Well, basically it means that because these participants are not using their visual cortex, some of that processing is taking place in other parts of the brain now. So the somatosensory cortex doesn't have to just keep using the somatosensory cortex. It can start picking up areas that are no longer being used, in this case, the visual cortex. And so you can kind of think of it as like they're better able to quote-unquote visualize that stimulus because of that. Once the blindfolds were removed, though, just in case you're wondering, people's brains did quote-unquote go back to normal. It did go back to baseline, so it wasn't like it didn't damage their vision in any way. But just kind of a cool way of how the brain can kind of change itself depending on its use and what is being prioritized. Alright, so that is it for that particular part of the chapter, talking about rubber hand illusion, body image, and phantom limb. We're going to be picking up for the final parts of this chapter by talking about pain. So I will see you there. Bye.